Hello, this is Mrs. Ross, and this is 2.1 domain and range of a function. And when I talk about domain and range of a function, I like to talk about our cousins from Arkansas, Dixie and Roy D. This is how I remember the difference between domain and range. So let me show you. So Dixie, domain, independent variable, x-axis, and input. Okay, Roy D. So we have range, we have output, we have y-axis, and we have dependent variable. As a matter of fact, these two i's are probably, it doesn't matter. But that's how I remember, if I'm looking for the domain of a function, I'm looking for x. Everything that it has for the x-axis, okay? And if I'm looking for the range of a function, I'm looking for y. Everything that it entails in the y, okay? Oh my mercy, set builder and interval notation. I copied this from your lesson, and it is hugely not helpful. So it talks about an open interval where it has parentheses, a closed interval where it has brackets, and then you can have intervals that are half open with a bracket. The bracket indicates closed, the parentheses indicates open. It says a non-ending interval where you have some infinities in it from either negative infinity or positive infinity, and then the non-ending interval of negative to positive infinity. So let's chat a little bit about this. I think it's better done when we actually do an actual problem. So set builder notation is a method of writing set numbers describing the properties. So this is set notation right here. This is set notation. That's what that is. There's braces, the left brace, vertical bar, etc. Interval notation is a method of writing numbers with parentheses. This is interval notation right here. So this is interval, this is set. And then it talks about open interval where the endpoints are not included. That's where you have the parentheses. And then closed interval where the endpoints are included. This is where you have brackets. And then you have the half open, half closed. There is an example here of x, the domain of x, where x is between 7 and 12. It includes 12, but it doesn't include 7. That's right here if you're looking. And that's a half open interval. The positive or negative infinity symbol for domain or range means it goes on forever in one or two directions, either the positive or negative direction. Let's see if we can actually apply this. So the function has a range of negative 25 to 84. So range, we know from Dixie and Roy D. Range is y-axis. So it says write it in set builder notation. So I know set builder notation has the variable here in a straight line. It has the chocolate chip. I mean they call it braces. I call it the chocolate chip. And I know that y is going to be between negative 25 and 84. And it includes negative 25 and it includes 84. So that would be your set builder notation. It says write the range in words. Okay, so I just said it out loud. Y is between negative 25 and positive 84. Okay, and that's range, which is y. Here we have a function has a domain, which is x, of all real numbers except 8. Okay, so for set builder notation, that's where we have the chocolate chip. Here, let me change colors. A. So we have the chocolate chip. I know that domain is x. For x is less than 8 or x is greater than 8, but it don't include 8. Okay, so that's my set builder notation. My interval notation, okay, so I know that this is going to go from negative infinity to 8. It doesn't include 8. And then it's going to go from 8 to positive infinity. And this is how I show this. And then normally there's like a little U. So that's kind of like an and. So I know it's all of the numbers. You know, if I were on a number line, it would be all of the numbers 0, and this is 8. All of the numbers here, and then all of the numbers here, but not this one. That's why we have, this is negative infinity, that's an 8. Negative infinity, and this is positive infinity, or just plain infinity. Okay, domain and range from graphs. So this graph represents a function. To find the domain, remember, domain, x, you look at the x values. To find the range, you look at the y values. Remember that an open dot means that that point is not included, while a closed dot means that it's included, okay? So let's see, the function in the graph above, x equals -2, that's this one. X will never reach, I'm so sorry, hold on. Okay, so let's do the domain and range of this graph. Domain, we know is x. So x is, let's see, that's -6. So x is greater than -6. Or x is between, hold on. Sorry, I was on the right track. I just did not trust myself, which is as per usual. Let's see if I can erase. Can I move this? Why can't I erase it? Well, never mind. Here we go. I want to erase. Okay. X such that, so x is between +4, so less than or equal to 4, and less than or equal to -6. So that's what that's going to look like. Or you can say it's going to be -6 and +4, and you have that because it includes +4. So this is going to be your set notation. This is going to be your interval notation. And then down here, the function above doesn't ever reach -2. So it has what's called an asymptote, a vertical asymptote at -2. The domain doesn't include -2. So as you write it, you know that it comes from forever. This is negative infinity over here. This is positive infinity. So it goes from negative infinity to -2, and it doesn't include -2. And then it goes from -2 to positive infinity, and we have that union or and symbol in the middle, okay? The range, so range is y, okay? So it actually just goes from, it looks like 0 to, so we have negative infinity down here, and we have infinity up here. So the range, so this would be your x, this would be your y, this would be your domain, this would be your range. Would be negative infinity to 0, because it goes from here up to here, and it doesn't quite, might touch the 0. Union, I don't think it includes 0, from 0 to positive infinity. I know that's a lot. I know it's gross. I'm just acknowledging it. Find the domain and range of the function. So, Roy D. Okay, so my x, oh, write your answers in interval notation. My bad. So let's see. So x, it looks like, if I look at the x axis, it starts at 2, and it goes to 8. So it's going to start at 2, and it's going to go to 8. Actually, hold on. Okay, pause. We've got to fit that middle thing in, right? So it's going to include 2. It includes -2. My bad. It includes -2 and goes to, let's see, 1, where it doesn't include 1. Union, and then we have over here, we have 5 to 8. So that's what it's going to look like. That's kind of gross. Let me see if I can make it a little bit easier on this side. So this is -2, and that is included. So that's what my set notation would be of the x. So of the y, or the range, or domain. Good grief. So for my range, let's see, so that's my y. So let's see, it starts here at, let's see, that's -7, and it goes to +2, okay? So I would have it includes -7 and goes to -5, but it doesn't include -5, union, okay? -5 to +2. Oh, wait, that's inclusion. We're including +2. Okay, delightful. All right, let's go on to the next. I lost my cursor. Okay, domain and range of this function. So again, domain, which is x, so that's this. So on the x, it looks like, so this is infinity, and this is -infinity, and it looks like it goes until, it doesn't look like it crosses the 4 for x. So I'm going to say it goes from -infinity to 4, and then from 4 to +infinity on the x-axis. So let me change colors. Okay, and then for range, or y, so this is -infinity down here, this is +infinity. So it goes from -infinity to 0, looks like 0, and then from 0 to +infinity. So -infinity to 0, 0 to +infinity. Domain from an equation. Okay, hold on just a second. Okay, to find the domain of a function, you have to set it to 0. So let's start with 1. So we have g of x is equal to the square root of 3x plus 4. Okay, so we're going to make this 0. Then we're going to square both sides to get rid of the square root. Then I'm going to solve for x. Sorry, ran out of room, bringing it up here. Divide by 3. And that is your domain. So hold on, let me show you how we write that. Okay. Actually, this is going to be, okay, so what I know about this radical is that it has to be greater than, it's not letting me write, greater than or equal to. Greater than or equal to. So, greater than or equal to. So this has to be greater than or equal to this. So what you have is you have, if you write it in set notation is, or interval notation, you have this and then +infinity. So it goes from this would actually be look like that. Okay, let me erase this and then we'll do 2. Okay, so funny thing, this has a cube in it, which means if you have a cubed x, or your degree of x is 3 or whatever you have, this is automatically all real numbers are your domain and range. So it can be set as from -infinity to +infinity because that covers all reals. And then this last one, I hope I can get it done. We're just looking here. So x squared minus 4, which is equal to x plus 2, x minus 2. So x can't be, I tell you what, I'll do this in the next video. This will be part 1.